In this episode I will show you how to miniaturize your Arduino projects with the use of ATtiny13. But you may ask, what ATtiny really is? It is a very popular 8-bit AVR microcontroller which typically has fewer features, fewer input-output pins, and less memory than other AVR series chips. The first member of the family were released in the 1999 by Atmel, later acquired by Microchip Technology. So let's talk a bit about ATtiny advantages and disadvantages over the Arduino. The big advantage of the ATtiny is that it is small. You can even buy ATtinys that are in the 8-dip package and they are very small. ATtiny is very easy to program with Arduino. You just connect 4 wires, 2 wires for the power and 2 for the UART connection. It supports PWM and I2C, which is very versatile in the electronics. But we need to talk about the ATtiny disadvantages. ATtiny has very low memory, so you are not able to write as big programs as for the Arduino. It doesn't support ISP, it doesn't have internal circuitry that Arduino have, for example internal fuses, internal voltage regulators, internal programmer, and it doesn't feature any kind of LEDs or indicators if it is powered on or not. Okay, so let's get now to the PCB making. If you want to make PCBs efficiently, easily and very comfortable, I think you should choose the EasyEDA software. It is very easy to make PCBs and it has a wide range of parts. And I will show you why. Okay, so let's get started. Here we have few tabs. The first one is the Projects tab, in which you have your projects, PCBs, sheets, and all the things that you have done in the beginning of your projects. Then we have the EELib, which is a very simple part collection from which you can choose very simple parts such as some simple fuses, quartz resonators, crystals transistors, diodes, LEDs and some other things. Then we have libraries, and I think this is the biggest part of the software because you can just write the Arduino, press enter, and then you can just find all the parts that you need. Of course, sometimes the manufacturer of the EasyEDA doesn't provide a single part that you have, but if he doesn't done it, some kind of user has done it, because you can contribute the parts that you have made for yourself to the whole community of the EasyEDA. And it is so much comfortable when you just open up the search libraries and just type in the part that you need, and then it just pops up on the first page when you just need it. Of course, some of the parts that are contributed by the users are not very much accurate. The spacing in between of the pins is not very much high quality. Sometimes you are not even able to name the ports, net ports of those parts, but still there are some very good contributors of some ports. For example, even Adafruit provides ports. Then we have the LCSC tab, which just ports you to the LCSC website and the JLCPCB, which I will talk about more later. So let's make ourselves a little project. You just open up a window, you need to name it, save it, and then you just have it. You have the sheet and the PCB. As you can see here, I have some kind of old PCB. But here we have a sheet, which I'm in right now. We can choose some very simple parts such as a capacitor and a simple resistor. Then we need to connect power to them, ground, and some kind of output, like that. So our project is done. It's very easy. If you want to wire up some things, you have all the tools in here, such as bus, wire, net ports, ground signs, net labels, and some voltage probes. So it's very easy to make something. And if you want to draw something on your circuit, you can do it very easily. If you want to draw something on the schematic, it's very easy. You can even write some text on your little project. Of course, all the parts have the attribute windows on the right side of the software window, where you can change the name of the part, you can display the name of the part or not, you can prefix some kind of name to it, show the prefix or not, you can lock it or not, you can change the package size, you can change the package display, you can even write the manufacturer if you really want in here. So you can change a lot of things in here. Then if you want to convert your project into a PCB, it's very easy. You just go onto the top of the window and you have here just a little single button, convert to PCB. But before doing it, you need to save the project. So let's save it like now. It needs to connect to the server and save the project. Then you just hit the button convert to PCB and it converts it. You can change the width and height of the laminate, but it's like, you know, the laminate piece on which you will be positioning your parts, but it doesn't really matter in our case, so let's just hit apply. Then we get to our single little PCB and our parts. Then you just grab them, position them on the PCB. It's very easy. And then to make the traces, you just pick up the tool which is called track, and then you just point it on the exact pin of the part, then just connect them together, and as you can see, we have all the names displayed when we zoom in. The net ports it's called. The pin of the resistor to which we have connected VCC is called VCC. The net port 1, which we connected to the lead of the resistor and the lead of the capacitor, is called net port 1, as it should be. And then we have the ground on the capacitor, and all the names are, I think, very good. So when you have done it and you're done with your project and you're so much proud of yourself, you can save it. Of course, we need to save everything, and you can name the sheet can be named differently than the PCB. So you can have, for example, a sheet which is named A and a PCB which is named B. Then we just hit the save button and it's kind of done. And then if you want to see how it turns out to be, you can go into the photo view and you can see all the net ports and part numbers and all the things, how it should look like on the PCB. But of course, to get like a more physical view of the PCB, we should get the 3D view, and the software provides it. We can just hit a single button and you can spin around with your newly made PCB. Of course, sometimes when you have not very good port that was contributed by some kind of user and he didn't done it very well, you will don't have the PCB mount position of the part. There are some parts that are only for schematic view and not for the PCB view, so you need to keep it in mind that some users doesn't contribute the spacing of the leads and pins and all this stuff in their parts. And that's really it. Then if you want to order it at some kind of manufacturer, for example JLCPCB or someone else, you can just hit the generate fabrication file, which is just a Gerber file. Then you can hit yes, check DRC. Then it checks it, and then you can just hit the button order at JLCPCB. Here you can choose how much PCBs you want to order, 800, 100 or 5 of them. Then we have the thickness of the PCB. 1.6 is the optimal thickness. Then we can choose the color of the mask, not the laminate itself, because the laminate itself will have like this a bit transparent white look, but you can choose the color of the mask over the parts, which can be green, red, yellow, blue, white or black. Then you can choose the surface finish. The surface finish is the finish of the mounting holes for the parts, where you can choose the normal lead finish, a lead free finish, or another some kind of finish that is, you know, with the European standard. You can choose the 2 copper weight. The copper weight is just to be as simple as possible. I can tell you that this is just a thickness of the PCB, because under that we have a few calculations and some other things. Not only the thickness of it, but all diameters are included in this 1OZ or 2OZ. You know, you have all the parts about traces, all the parameters about traces under that number. So it's just too much to talk about this in this episode. Here you have the manufacturer, which is the JLCPCB, and a price for 5 PCBs is just $2. And the estimated delivery time depends on the shipment provider that you choose. But you know, like the optimal one is from 3 to 7 days, but if you will choose some kind of cheaper providers, you can get even up to 15 days. And then you just hit the button order at JLCPCB and you will have your PCBs ordered. Schematic is very easy. As you can see, here we have the voltage input, which is minimal 7 volts. It gets smoothed out by the 1 microfarad capacitor. Then it goes into the 7805 voltage regulator, which is connected obviously to the ground, and then we have the output, which is smoothed out by another capacitor. Then we have the indication LED that shows us that we have hooked up the power and everything works. Here we have the external header to the power if you want to connect it to some other parts, which is connected to ground and to the rectified 5 volts. And here we have just the pinout for the 80 tiny, so we can connect everything very easily. I have ordered PCBs at JLCPCB.com and I have received them 2 days ago, and I can show you them. They look very good. All the traces that I have implemented are here. Even the vias that I have implemented are there. As you can see, we have a little pin here connected to the via to the other side of the PCB. It goes here, here and here. Then it connects to the other via, goes onto the other side, and here we have it connected to the IC pin. Of course, you don't need to do vias to connect part leads together. You can do it just on the other side of the PCB, but I didn't want it to pass the traces in between of the IC pins. The PCBs look very nice, the masking color is very nice, the printouts are very nice, and I think that's all that I can tell you about those PCBs. They are just very well made. So now we need to solder all the parts. All the mounting holes for the parts are metallized inside, so soldering is just a very easy process in this PCB. Even IC was very easy to solder on, and everything just works. If you were not soldering up to this point, I think you should try it with the JLCPCB PCBs. They are very easy to solder, and you can learn how to solder SMD parts. Okay, so let's explain how this circuit works. So here we connect the power. Here we have the screw down terminal for the power. I have written in here that the minimal voltage is 7 volts. Then it connects to the voltage regulator 7805. As you can see, it regulates the whole voltage to the 5 volts from the minimal 7 volts on the input. Then it's smoothed out by the 104 capacitors, 100 nanofarad capacitors, right in here. The input and the output is smoothed out by these. Here we have little LED indicator with the resistor that powers on the LED, which shows us that we have connected the power and everything works. Here we have two male headers for connecting some external things such as displays, motors, relays, MOSFETs, MOSFET drivers that we can connect the power from here. Then the power powers up the IC, and we have in here the pinout for the IC. As you can see, the digital pin 1, which supports PWM, digital 0 pin, which supports PWM, analog input 1, digital 2, analog input 3, digital 3, analog 2, digital 4, and a reset pin. And that's really it in this project. The whole protection, which is the short circuit protection, over voltage, over current protection, is inside the 7805 IC. So let's get to the Arduino / ATtiny programming. To do the whole thing, you need to connect the ATtiny to the Arduino itself, which is very easy, and I will show you how to do this in a moment. But now let's get to the point. Firstly, you need to turn the Arduino into a AVR ISP. To do it, you need to go to the File, Examples. From the examples, you need to choose the Arduino ISP and upload this sketch to your Arduino. Wait for it. And then when it's uploaded, you are done with turning your Arduino into a AVR ISP. Then we need to install the hardware package for the ATtiny. This depends on the exact ATtiny that you are using. I am using ATtiny 13, so I will install hardware packages for this exact model. We need to go to the file, then go to the preferences. Then in the preferences we need to add here a link. In the case that you are using the ATtiny 13, you need to copy this, paste it in here, and then hit OK. So you have added the hardware package for this. Then to open this hardware package, you need to go to the Tools, tab, Open Board, and you need to find the Boards Manager. In the Boards Manager, you need to find Micro Core and click Install. So let's write in Micro, and here we have Micro Core, and then we need to hit Install. Then, if we have done it, you need to connect the hardware. So we will get to this in a moment. Now you need to connect the hardware. The first leg of the ATtiny should be connected to the Arduino digital pin 10. The leg 5 should be connected to the Arduino pin 11. The leg 6 should be connected to the Arduino pin 12. The leg 7 should be connected to the Arduino pin 13. The leg 8 should be connected to the 5 volts and the leg 4 should be connected to ground. After that, we need to change some settings in the Arduino IDE. We need to go to the Tools tab, then select the board, which should be the ATtiny13. Then we need to set the baud to the 4.3 volts. Then the clock should be selected to the 1.2 megahertz internal oscillator. Then we need to set the compiler LTO enable, which is enabled by default. Then we need to set the Arduino port to your port that you have on your computer, and then the programmer Arduino as ISP. When you have done everything like that, now you can burn the bootloader. So now we need to go to the tools and hit the burn bootloader. There will be an error, as you can see, but it's displayed as an error only because of the Arduino IDE. It works fine, as you can see. Everything is done good by the AVR dude. And now we can upload very simple sketch. We should be able to upload this sketch. I have a little sketch right in here which should blink an LED. So we can try uploading it. We need to save it, then it uploads. And then after it is uploaded, it should blink an LED. Now, as you can see, the whole circuit is working. Now I will remove the ATtiny from the breadboard when it's now programmed, and I will hook it up to my ATtiny development board. Now, after removing the IC from the Arduino programmer, I have plugged it in to my little ATtiny development board, and as you can see, I have hooked it up to my lab bench power supply, which is set it to 9 volts. And now I can very easily miniaturize my Arduino projects if I need only 4 or 5 digital pins. As you can see, the circuit is very small. The ATtiny is very easy to program with Arduino as ISP, and you can miniaturize your projects with it. If you want to see more videos like that, please subscribe to my channel and visit my website ardugeek.pl.